Good morning. I'm Tim Corbridge, the Director of Sales for Ally PLM Solutions. I'd like to welcome you to our session this morning on improving technical documentation with Cortona 3D. I'm joined by Paul Mass. Paul's an application engineer here at Ally PLM. He specializes in the Cortona product. I'm going to give you a brief overview of the product and applications for the product, and then Paul will do the real work, which is a demonstration. The session this morning, I'll do a brief overview of Ally PLM Solutions, then a brief discussion of Cortona 3D. We will talk a little bit about the business challenges that face many of the customers that we work with in the technical documentation area. We'll follow that with a solution overview and then a demonstration of Cortona. We'll have a few minutes to talk about case studies and references, and then some time at the end for questions. Ally PLM Solutions is a product lifecycle management solutions provider with expertise in computer-aided design, computer-aided manufacturing, computer-aided engineering and product data management, as well as technical documentation. We're a gold-level Siemens solutions partner. We deliver and support the complete line of Siemens PLM products. These include tools for design such as Solid Edge and NX Unigraphics, NX CAM or CAM Express for manufacturing, FEMAP, NX CAE, MoldX, and SigmaEdge for analysis. And the tool we're going to spend the time talking about today in documentation would be the Cortona 3D product. We provide not only the software in these areas, but also provide training, support, and mentoring for all the solutions we provide. We cover a large portion of the eastern half of the United States, as you can see from the map on the screen. Cortona Rapid Author product is a leading tool for technical communications. It enables technical authors to create web-based 2D and 3D output. The key to that is, again, both 2D and 3D output. We deliver that information in both web content and in print-focused content. Typically, the print-focused ends up being a PDF file. Cortona is the only tool that can create business-ready, standards-based documentation across the 4 areas that are shown on the slide: work instructions, parts catalogs, technical manuals, and computer-based training materials. We also have a viewer that's used broadly. There's over 10,000 downloads each month of the Cortona 3D viewer that's used to view those documents. You can see on the right-hand side of the slide some of the reference customers who are using the product. Maybe one of those that you'd be familiar with would be Winnebago, the RV company. They do all their spare parts work with Cortona in their latest products. If you're a dealer ordering parts for a Winnebago, you're doing that via a web-based implementation of the Cortona parts catalog application. The Aberdeen Group is an industry analysis group with a practice in the area of technical publications, and recently did a study of business issues facing OEMs or equipment manufacturers in the technical documentation area. Some of the challenges they face are accelerating product volume and complexity. I think of that about my cell phone, and they want to replace my cell phone every year. And those kinds of pressures have increased the need for better tools for producing documentation for the companies that produce those products. Users are demanding better quality documentation with another key finding in that Aberdeen study: shortened development cycles. Some of that based on the shortened life cycle of product is also creating pressures in the business world, as well as increased competition in trying to maintain market share. As you look at that in the technical documentation area, that leaves 3 business challenges there. The capability to reuse existing content or existing assets to help reduce time to market, address some of that increasing or accelerated product volume. The reduction in reliance on text-based instructions. One of the other items from the study from Aberdeen was the increasing cost of internationalization or localization of documentation, and obviously a reliance on text instructions increases the need for that documentation to be translated into local languages. And obviously, customers are continually looking for improved user experience in the technical documentation area. If you look at the typical design process, you see on the engineering side of that process, design, test, and build functions. The data typically used for those processes stored in the CAD system, some type of BOM, bill of materials system, an ERP system, perhaps a product lifecycle management system. The delivery and support portion of that company, typically characterized by additional documentation written by hand, using digital photographs, sometimes manually created illustrations independent of the engineering data. That technical documentation is typically delivered in either a PDF format, which would then be delivered on a CD, or still in many cases printed documentation. In most companies that we work with, there's some kind of wall between the engineering and technical documentation organizations, which makes transition of that data between the two difficult, causes business issues, as you see there on the slide, launch delays, limited output formats, duplication of effort to create that material, etc. So if you look at the business value, the current processes of many of the companies we work with, they're based on a 2D or a static print format, or typically a PDF that's then printed. Most of the illustrations of those companies are done manually and not taking advantage of some of the material in the CAD system. There's a lot of use of digital photography, and typically text and graphics are authored in two different systems. A lot of times there'll be office tools such as Microsoft Word combined with digital photographs, or in many cases PowerPoint, to try to create that information. The opportunity there from the equipment manufacturer is to utilize that information from the CAD system and from the existing bill of material, as opposed to duplicating that information. That's one of the areas we focus on, is reusing those existing assets. We typically talk about authoring that material once and using it in many places. We reuse and repurpose that data, the information coming out of the CAD system and the bill of material system, and use that data not only in the systems that are there today, but in the technical publications area as well. And then the other key portion of that from our perspective is integrating the text and graphics information into a single environment so they can be authored together. The result of that from the equipment manufacturer is a reduction in both the cost to produce those technical documentation materials and a reduction in the time required to create those materials. If we take that a step further, and we typically call this a value at the operator level, or is usually in a company's case it would be your customers, what kind of issues do your customers see as they operate your equipment? The first one is in product reliability downtime. This is typically around spare parts, if they need to order spare parts. When a piece of equipment's down, waiting for those spare parts is a critical portion of their business. And by using the Cortona product to create parts catalogs, you significantly reduce that. You also reduce the part identification errors. I think you'll probably not find it unusual that wrong part is ordered, gets shipped to the customer, shows up, they've got a piece of equipment down, they now have the wrong part, they have to reorder the part. It's not only additional downtime associated with that, but there are costs associated with restocking that part, reshipping that part to both the operator and the equipment vendor. The other portion is a key issue there is the cost of training. How much does it cost to get individuals, either repair technicians, etc., trained on how to do operating or repair on that, and the maintenance effectiveness and other issues. The opportunity that Cortona then gives you access to is producing better quality documentation to address those issues, both in the parts catalog area and ordering spare parts and getting the right part the first time, and then also in the service manual and training area, being able to improve aspects of that as well, so you get accurate parts identification, decreased downtime, and improvements in the training time or reduction in the training time. So again, there's two levels of benefits there. One comes directly to the equipment manufacturer, and then the second one is one level below that, which is to the operator or your customer. Obviously, producing better documentation for them improves your customer, the value you deliver to your customer. So there's just a couple of companies who are using the product, some of the results they've seen. We'll talk a little bit about GE more at the end of the presentation, but it used to take them significantly well over a year and multiple people to do their product documentation. They've now taken that down to 7 months with just 2 people. Very significant improvement. You can see some of the other results there. Again, we'll talk about those more at the conclusion of the presentation. Before we turn the time over to Paul, I want to give you a brief overview of the tool itself and the concepts behind the tool that will help you understand as Paul begins his demonstration. It all starts with the source data. I said before that we follow the maxim of create once, use often, and that begins with your source data that is in any of the major CAD formats that are out there today, as well as the JT format, which is exclusively used specifically in the automotive industry and from the Siemens product family. In addition to that, there's information stored typically in an MRP system. That's the bill of material that goes with that. That's either an engineering bill of material or in many cases a service bill of material, which will be a little bit different than the engineering bill. We have the capability to work with those inside the Cortona product. You also have other assets that are available that can be incorporated into Cortona, such as digital images, textual information coming out of a tool like Microsoft Word, CGM graphics, XML documents. Again, all those tools, all those existing assets you have. We then bring that into something we call a project, which is within the Rapid Author Suite. The tools there then allow you to work on that data in multiple areas. We'll talk a little bit about those briefly. You can kind of think of Rapid Author like you might think of Microsoft Office, that there are separate tools within Rapid Author, just like Excel and PowerPoint are different tools within the Office suite depending on the application that you want to use. So within the Rapid Author suite, you have the catalog tool, which lets you quickly and easily create interactive parts catalogs. You have the work instruction tool, which lets you create and build procedures for manufacturing assembly where a production technician has to follow a strict set of instructions or paths to achieve a task. You have the manual application, which lets you create animated as well as static 2D operator instructions or service manuals. And then finally, the learning tool, which builds upon those tools and lets you create interactive computer-based training scenarios to improve operator and service effectiveness. We then deliver that information from Rapid Author into a number of output formats are available. The probably most common one of those is directly to a web format via the Cortona 3D viewer. We also have the capability to output the individual components of those documents, be them XML files, images, CGM files that you could then put into a content management system. That data can also be output to a PDF file, either in 2D or 3D, and of course available on mobile platforms such as the iOS on the iPad or iPhone, Android, and the Windows mobile environment as well. So as I said, the real key to the Cortona product is authoring the information once, using it across all of those applications, and then being able to publish that in any format, whether it's web consumable, some type of print format such as a PDF, or on a mobile device such as an iPad. We do that in a standards-based environment, so if you're doing aerospace work, for example, we comply with the S1000 format. In the more traditional document content management, we support the DITA format, and in a learning mode, we're completely compatible with a SCORM-based learning management system. We also provide, as part of the suite, we provided Ally, a content management tool based on Siemens Teamcenter engineering product, if that's a tool that you would need as well. So with that, what I would like to do is turn the time over to Paul and begin the demonstration of the product.
Thanks, Kim, for that intro. As Kim described a little bit of the tool and its capabilities, what I'm going to do today for the agenda is start out by showing you a couple of published examples of what Cortona can produce, and then after we take a look at some of those examples, we'll go through a few processes of how to create maybe a page of a parts catalog and then later a process in the manual. So what we see up on the screen now is an example of what published output would look like. This would be an HTML page that you would have displayed on your web page, or could be dispersed through a CD, or even uploaded to an iPad. And notice that the 3D graphics window is completely interactive. This is what the customer would be using. They would be able to rotate the object around. I'm able to zoom in and zoom out. I have the ability to pan the object across the screen. And notice that when I hover over a component, it highlights back to the parts list on my right here of which item I'm hovering over. If I select it, it highlights in yellow. I'm able to just change the display of that object if I want to. Maybe if I want to hide this case and see the internals of this pump, I'm able to do that. So pretty cool stuff there. It's not a static image, it is completely interactive. Up here on the top, if I wanted to print the graphics, I can just print the graphics window. Maybe I want to apply some callouts before I print that graphics window. All I have to do is highlight the item, and then I can pull a callout off to the side. I'm able to hide the parts list if I only want to see the graphics window. I can print the table if all I want to print is the table, and I'm also able to do a composite print. You know, once I got the view to where I wanted it, I could composite print the graphics and the table. Over here are the different sheets that are available to me. If I wanted to get a look at just that backplate assembly view, I select the sheet, it automatically animates to that sheet, and notice it's still interactive here. I'm able to rotate that around. The parts are still hot spotted. If I wanted to see a 2D image of this view, all I have to do is click on the 2D graphics button, and it's going to take me to an image that was created in Cortona. This is not a CAD view. This was created actually with the rapid authoring tools, and we'll get to take a look at an example of how to create something like that as we move through the demonstration. There's some other views we can look at here. Maybe if we wanted to see the drive shaft view, it's going to automatically move us to that view. There's a couple levels here that we can take a look at. If I want to expand to the relief valve assembly, I'm able to do that. Again, these come complete with the 2D graphics as well. Or maybe I have a section view where I have the entire assembly sectioned in half so that I can see the internals. Again, this was not created in CAD. This was actually created in the rapid authoring tools. It's pretty cool stuff. This is really going to set your company apart above your competition. It's going to make parts ordering easy and less chance for error when the customer or the vendor is ordering parts. It's always great to have a graphic representation of, so I can see what part I'm ordering. And we could have this configured, maybe a column over here linked to an e-commerce site or a shopping cart, that once I've distinguished which part I want to order, I could maybe say over here, add this to a shopping cart, and streamline that whole parts ordering process. So this is an example of what a publish output would look like. And let's get into the actual tool and see what that process would look like to create one of these parts catalog pages. As Kim mentioned before, Cortona 3D comes with a suite of tools known as rapid authoring tools. We can see here the layout is similar to what we would expect for Microsoft Office suite. The first tool I want to look at today is the Rapid Catalog tool. To get started, all I have to do is come up here and do File, New Project. I'm going to assign the project a name. Then I want to pick the specification I want to apply to this certain project. Kim touched on that briefly. We have some of the ATA specifications and S1000D specifications available to us out of the box. For this example, I'm just going to do a generic IPC. By the way, IPC stands for Illustrated Parts Catalog. Once I've created my project, I'm ready to import some data. This is going to fire up the Rapid Generator import tool. Notice here that we support all the major CAD packages, whether it be CATIA, Inventor, NX, ProE, or Solid Edge. We could also have a plugin configured to apply your company's specific business rules for pre and post processing, which is what we've done here for this demonstration today, the Pump Demo plugin. This way I'm able to go out and grab my bill of materials Excel spreadsheet, whether that be off of my local computer or from an ERP system, and I come out here and grab my CAD data at the same time and select OK. What the Rapid Generator tool is doing right now is it's going to remove all the intellectual property from the CAD data, not only simplifying the project output and creating a lightweight package, but it also prevents from reverse engineering. We don't want to give out our intellectual data to anybody out there in the world. We can close down the Rapid Generator and see that our CAD data has come in. Take a brief minute to explain the layout of the Rapid Catalog interface. Over here in my item tree, this would be similar to what you would see in CAD as going to be the assembly structure. I can see all the components in my assembly. I have my top level assembly there. Notice that as I pick it, it highlights it in the 3D graphics window. Or I can pick it over here in the 3D graphics window, and it's going to come back and highlight where that component lies in the assembly. So it maintains CAD structure, which is really nice. We're also able to view these components in a list if we want it broken out from that assembly structure. And then if I want a graphic representation, maybe I don't know the part number, but I know what the part looks like, I'm able to come over here to the thumbnail tab and scroll down, and I can start seeing a little thumbnail of any component I want, and I can pick it that way. Down here at the lower portion of the tool is my parts list table. DPL stands for Detailed Parts List. Basically, this was the bill of materials that got pulled in, which is, we can edit this manually if we want. It's completely interactive. Maybe if I wanted to spell out assembly, I could add that. So after importing our CAD data and our bill of materials data, we're able to run a discrepancy log, because sometimes we have mismatches between CAD data and bill of materials. We all know in the engineering world that sometimes the person responsible for creating the model maybe doesn't communicate with the person responsible for keeping up the bill of materials, and we may have mismatches. So we run a discrepancy log, see exactly what is going on with our data here. Notice that the parts in light green indicate a complete match. They matched up just fine. That, okay, I have this CAD data and I have this row in the parts list, and the match was fine. This dark green row here indicates that the quantity seen in the parts list exceeds what has been brought in with the CAD. I know for this example that really I only need 6 of those bolts, so I can go back to my parts list table and edit that. The row here seen in red shows me that there is a row in the bill of materials, yet it's not linked to any CAD data. It's not saying the CAD data doesn't exist. It's just saying that those two aren't linked up. So it's going to be up to me, the author, to go investigate that discrepancy. Lower down, a little bit lower on the list, we can see a couple rows highlighted in blue, which are also known as background or reference items. Often we know that a service bill of material may include kits, such as a poppet and spring in this example, where I don't want to have the poppet listed as one item and the spring listed as another item. Maybe I want to order those as a kit, or that's the only way those are available to be ordered. So that's just saying that there's not a DPL related to these two components, and that's fine because I can see that they're part of assembly here, the poppet and spring. Once I'm done looking at my log, I can come back into the tool and try to link those parts up that weren't maybe matched together. one way to do that is to come over here in my item tree and look at the symbol next to each component. The components that have a blue dot with this little orange square down here by it, which is really a little arrow, I'm not sure if you can see that level of detail in the demonstration, that's telling me that it is linked to a row in the DPL. Notice this item here only has a blue dot. That's the casing. I can also come down here in my parts list and look for a row that doesn't have a gray dot next to it. That is also an indicator that this row is not linked to a 3D graphics. So once I have distinguished the two, and maybe this was just an error, we can see here that in the parts list the part is PM005350. Up here in my item tree I can see that it's PPM. So I'm able to manually edit that in the item tree to make that just be a PM part, or I could come down here and add a P to my parts list row if I want to, if it was really supposed to be PPM. But I'm going to think the other way and think that maybe the CAD model was named incorrectly. I'm going to go with PM00530. So to link those two together, I just select my component in the 3D graphics. I select the row I want to link it to, right-click, and have select link graphics, or edit with link graphics. My links editor menu comes up. And we can see that the available 3D graphic items, the one that I have selected, pre-selected, is highlighted there, and all I have to do is hit link and OK. I now see that the symbol next to my case over here has a little orange glyph by it, and the row in my data table has a gray dot in it indicating that those two are linked. So once I've handled all the discrepancies, or am confident that everything is linked together, I can now come over here to my IPC pages or my parts catalog pages and start creating parts catalogs. The scene can be thought of as the entire book, and the pages underneath that are going to be individual sheets within that book. So the first thing I want to do is reassign a name to that sheet. And the next thing I want to do is set the viewpoint for that page. This is going to be the position of the camera when I activate that page. So notice that the page that I'm working on right now is shown in bold. That's the activated page that I'm applying commands to. Now that I have the view the way I want it, I can come up in here and set Page Viewpoint. That's where my camera is going to start. And notice down here in my parts list that all the rows have gone to a kind of a light gray color. This indicates that they're not currently active on that page. In order to activate those rows so that they match 3D graphics, all I have to do is right-click and do Activate with Visible Geometry. Notice now they're all in bold black, and these are going to be the rows active on that page. If we wanted to add a company logo, we could come up under here, Tools, Options, to External Logo Type. And I'm just going to select the logo, and we can preview so far what my published output would look like. Notice here that we got my company logo down here in the lower right hand corner, a completely interactive 3D graphics scene as we saw before. No other sheets are available to us yet because we haven't created them, but notice that everything is hot-spotted, including that case that initially showed as a discrepancy in the discrepancy log. So let's go back into the tool. Maybe we want to create another page for the casing view. And maybe I want this sheet to be a child of the assembled view. First thing I want to do is rename this sheet. And then I want to activate that sheet. The next thing I want to do is choose the parts that I want to be displayed on this sheet. I can simply do a window select. Hold down my control button to select all of the components I want to keep on this sheet. Invert that selection and get rid of the components I don't want to have on that sheet. Now notice I hit a red X there. That didn't delete the components from the whole entire project. It just removed the components from the sheet that I don't want to be displayed. I can come up here and do Show Deleted Items, and any component that has been hidden or deleted from this sheet is going to have a big red X through it. Notice that all the rows in my parts list have gone back to a light gray color, showing that none are active yet. I just want to repeat that same method of activating with visible geometry. And maybe I want to deactivate that row in specific. So now we can see that the only things that are going to be active on this sheet are the ones shown in bold type. So now I want to create an exploded view of these components. I just want to select the components I explode, select the linear explosion, and then drag my manipulator so that it is in the correct orientation. And I can either drag the vector for the magnitude, or I have the option to come over here and type in manually the value of the magnitude I want to explode those items out. Maybe I want to explode these components up here as well and follow that same procedure. Now that I have my items or components exploded in the way I want them to, I can set my view how I want to have it displayed on my parts catalog sheet, and come up here and select Set Page Viewpoint the same way we did for the assembled sheet. And now it's time to generate a 2D image. Notice that this is all built in with Cortona. It even has the ability to apply callouts. And once I'm happy with the position of my view and the callouts, I can come over here and hit Create 2D Image. Give this image a name. And if I want to edit this image, all I have to do is hit Edit, and Cortona comes out of the box with the 2D editor. I'm able to add callouts or add hotspots. Maybe I want to add some text up here. Make that a little bit bigger so we'd be able to see it. I can add lines or curves. And notice that this isn't a TIFF or JPEG image. This is a CGM, which is a vectored graphic image. It's smarter than a TIFF or a JPEG. Normally, if we were going to zoom up on a TIFF or a JPEG, things would start to get pixelated. This is much more powerful than a TIFF or JPEG. Once I'm happy with my 2D image, all I have to do is hit Save, exit out of the 2D editor. Select OK there. And now let's take a look at a preview our published output. So notice here we have the assembled view sheet. We can come down to the casing view that we created. It's going to automatically animate to that view. We're able to spin things around. We can see those explosions that we created. We're also able to see that 2D image that was created within the tool. If I wanted to create, so maybe your customer is a mining customer, and they're deep down into a cave and they're not able to have an iPad with them or access to a computer. I am able to publish this. Once I hit save, I'm able to publish this as a 2D PDF document, and then they could choose to print that out and carry it down to the mine with them. We can see here that the view's been created for us, and here's the parts list as well. No manually typing, all automated. Once I create the 3D parts catalog, all I have to do is do a couple clicks to get a 2D print of the same thing. So now we've done, that's the example I wanted to show for the Rapid Catalog. Really powerful tool. It's really going to wow the customers when they go to your website and see how easy it is to order parts. The next thing I'd like to take a look at is something that would be produced in the Rapid Manual tool. And this is an example of using the data specification. This may be a typical workflow for a maintenance procedure on this pump. We can see here a picture that's been added, and we also have the steps in this procedure in text to our left here. But if we wanted to see a 3D procedure, all we have to do is hit the 3D button. Notice, let me pause this for a second. This wrench that came in is going to be supplied out of the box in the object gallery that comes with Cortona. We have some typical standard tools that are going to be supplied. We have some wrenches, socket as you see here. There's an oil can, a couple other things. If there's a tool or item that you use commonly specific to your company, you can add that to the object library and bring that in whenever you'd like. This doesn't have to be supplied with the CAD data. So we can see as it goes through the procedure, it's going to track down on the left side through the text, and we're going to see the animation in our right. If at any point I want to pause this and rotate it around, again, it's still completely interactive. This isn't a flash video. It's going to display a couple labels for us, telling us what to look out for. There's that section view, which may look familiar from the parts catalog. So this wasn't completely recreated in the Rapid Manual. It was, we can take something that we created in the parts catalog, bring it into Rapid Manual, apply some actions to it, and create a procedure so that we're repurposing and reusing some documentation that we've already created. So there's no double work in creating a manual. It's going to put those back together. It can flash us a message saying, ensure that all bolts are tightened to 25 Newton meters. The viewer has to acknowledge that message by selecting OK. Again, we have a label out there to like kind of a double reminder showing us how to put the pump back together. It's going to show us how to adjust the relief valve, and our maintenance procedure is complete. So now let's go into the actual Rapid Manual tool and maybe create an inspection procedure to inspect those propellers. I don't have to create a new I can do open project. I don't have to start from scratch. Like I said, we can repurpose what we did in the Rapid catalog. I can do an open as. We'll choose our specification as a Ditto 1.1 task and select OK. I'm just going to get some information telling me that I'm switching from a catalog to a manual and that my parts list information is going to be discarded. I'm OK with that. Then I want to do File, Save Project As so that I can maintain my parts catalog, and now I want to create maybe a manual. The layout's similar to what we saw in Rapid Catalog in that we still have a 3D interactive graphics window. We still have our scene tree over here with the same thumbnails down at the bottom. And we have over here, we're going to have our metadata table. Down below is the procedure editor where I'm going to manage and apply actions to this procedure. So the first thing I want to do is add a step. Maybe we'll just call this step 1. I'm going to make it a child of the overall task. Once I have a step in place, I can then create an action. And notice that the actions we can apply to our components are described in simplified technical English. So we have actions such as inspect the object, which is basically going to flash the object a different color a couple times. We have actions such as install the object, pretty self-explanatory there. Open, close, remove the object, remove threaded fasteners. First thing I want to do is point the camera to the object. This is going to set my viewpoint or position my camera for the initial view I want to show at the beginning of my procedure. First thing I need to do is select my top level assembly and apply that action point the camera to the object, select refresh. Now maybe I want to remove one of these bolts. Maybe I want to zoom in and get a little bit closer. Now that since I have my object selected, I can choose the action I want to apply. I'm going to do remove the object, select OK. Then I can expand this to show the elements that are in that object or in that action. Set viewpoint. Since I chose to set my viewpoint before applying this action, I don't have to go in here and edit it. If I wanted to, I could. Maybe I wanted to set it a little something like that, and then I could just do use current. It's going to snap to that. It's going to move the camera to that position. I do need to come in here and specify how I want this bolt to be translated or transformed. I can simply drag it out on the screen. Maybe I do like my viewpoint a little bit more like that. And I also want to apply it maybe screw 1.5. Select OK. If I refresh my task, take it back to the beginning, I can get an idea of my animation so far. The next thing I want to do is take out the remainder of these 3 bolts. So I don't have to, all I have to do is duplicate that action and replace the object. Maybe I could duplicate it a couple more times to get the other bolts as well. Follow that same procedure. Just choose my object. Anything that's underlined over here under the procedure editor is able to be edited. Once I have those correct objects, I can hit refresh. Get a preview of what my procedure looks like so far. And of course, we wouldn't want to have to sit through those being removed all independently. So if I want to have them be removed simultaneously, I could come under here and add an action union and then move these 4 actions under that action union. Now I'm able to hit refresh, and now let's see the difference. All my bolts are going to come out at once. So now I'm ready to remove. I'm going to add a second step here. I want this to be step 2. I want it to be a child of the main task. If I want it to be a sub-step of step 1, I could have chose it to be a child of step 1, but I want it to be its own new step, so I'm going to put it under task, give it a description of step 2, select OK. The next thing I want to do is remove the flange in a similar fashion that we removed the bolts. And then I want to remove the gasket behind it, but I don't. It's so similar to the removing the flange that I can just duplicate that action as well. Replace the object. We can see what our procedure would look like thus far. So maybe now that since we have the flange off, we can get a better view at this propeller in here, and we just want to add a step to inspect that propeller. Similar to the process before, we're just going to add a step. We want to inspect the object. Basically what that's going to do, it's going to draw the viewer's attention to that object by flashing it a different color a couple times. In fact, I think the default color is yellow, so we may want to change that color down here to maybe blue. So if we were to bring it back to the beginning, we'll see our bolts come out. Our flange and gasket. And it's going to flash the component to be inspected. Maybe if we want to draw a little bit more attention to it, and I touched base on this earlier a little bit, we can add a call out. This was the object gallery that I spoke of earlier. We can see that we can add call outs. We can add sections of hosing, maybe some rope or a spring. Down here are some of the tools that I mentioned earlier, an oil can, a hammer. We could always use a hammer to, you know, whether you're having a tough time getting something apart or putting it back together, a hammer is always a useful tool. There's the torque wrench that we saw earlier. But I want to add a call out, so I'm just going to right click and do add to project. And I want to say inspect propeller. Bring it into view there. Pick where I want my reference line to be attached. Say OK. Now I can see my call out down here as another component in my scene tree. That I can perform actions on this call out the same way I would do to any other component. Pull it out here a little bit. Once I got the position set, now I can perform an action on that label. Maybe I want to have it be shown for a little bit and then hidden after we're done with step 3. So I can select the call out, apply an action of show, hide the object. And then we're going to see the call out come up. Now let's say if I wanted those two to run simultaneously, and actually that command runs a little long, so if I wanted to decrease the length of the show hide, all I have to do is come over here to my timeline and drag that back maybe to 1.5 seconds. Now we can see it's just going to display that call out for about 1.5 seconds. If I wanted to have the object flash and the call out be displayed at the same time, I can do the same thing by applying an action union here and moving these two actions underneath that action union. Pretty cool. So now that we've had the pump apart and we've shown the user what they need to inspect, we obviously need to get this thing put back together. I don't have to go through the process of creating those steps and actions again. I can just duplicate these steps, move them to the end, and then invert them, which is going to change a remove to an install. And from the top, fast forward through here a little bit, we're getting close on time. Have the inspect action. Now it's going to bring these items back in. Just with a few mouse clicks, I get my pump put back together. The rapid authoring tool does come with a document editor. It's going to automatically generate the document for me. Maybe I want to insert an image here. let's preview our output now. So here we have the 2D text and the image that I just imported, similar to what we saw earlier. Completely interactive. So I spent some time as a repair process engineer for an airline company where I had to go down to the shop floor and speak with shop mechanics and take pictures and use Microsoft Word, Microsoft PowerPoint to come up with a Word document. And I always hated fussing with the formatting of Word and drawing simple line pictures with PowerPoint. If a tool like this would have been available to me, my job would have been much easier and I'd have been more efficient and productive. So I think we're doing leaps and bounds in today's day and age with products like this. It's really going to help out your TechPubs authors be more efficient and produce a product that's really going to wow not only your staff, the people you train, but the customers that you do business with as well. So that's about all I have for demonstration of the software. I'm going to turn it back over to Kim to wrap up. Thanks.
Okay, we appreciate your time this morning. One step that we didn't quite get to is there's the learning tool. We have the capability also to take that manual information and turn that into an interactive learning tool with capability to three levels of activity with that learning tool. One's a learning mode, an instruction mode, one's a learning mode, and then the third and final one is a test mode where the student could take a test to see if they've learned those procedures. So again, that's all part of the Rapid Author product. So what you've seen today is a tool that is very easy to use and intuitive. Doesn't really require a CAD engineer to be able to run it. It's more focused at technical documentation people. The capability to link graphics and text together is very flexible and configurable. Some of the formats and style sheets that we use give us the capability to customize that or to configure that specifically for a company. And then the end user experience, again, the operator of the equipment has a much better environment to both learn those procedures and use the equipment going forward. Just quickly, there's a quick case study on GE Aviation. You're probably mostly familiar with a jet engine. That's what GE does. Gas turbines and jet engines for military industrial applications. They had a manually intensive authoring process. They were using about 12 people to generate that parts catalog. They had a problem with updates. They could never keep it up to date when there were changes to it. They have a large number of airlines that they need to provide that information to. They have replaced that product with a complete 3D documentation solution where they reuse their data from their CAD system and the Cortona product to produce that information. You can see some of the metrics here. They've taken that process from 2 years and 14 people down to 7 months with 2 people to produce that information. So they're getting better quality documentation to their customer, which typically is the airline, getting it to them earlier in the process, helping them reduce their cost of training, and being able to deliver those updates on a much shorter time frame, all while doing it with far fewer people in less time. Well, folks, we appreciate your joining us today. If there are any additional questions, you can get in touch with us, and we can address those for you. Thanks again, and have a good day.